Photochemical smog. So the combustion of fossil fuels produces primary pollutants that may in turn become secondary pollutants and then lead to photochemical smog, selected secondary by topography, population density, and climate. Photochemical smog has significant impacts on societies and living systems. Here's some economic costs, as well as some health effects, which we've talked about in quite a lot of detail. Here's an example of how ozone forms. Maybe you just watched the video about stratospheric ozone. Here we're talking about tropospheric ozone. So you might notice this nitric oxide. This comes from burning fossil fuels, and that's actually what helps create tropospheric ozone, making it a secondary instead of a primary pollutant. Photochemical smog can be reduced by decreasing human reliance on fossil fuels. So primary pollutants from the combustion of fossil fuels include carbon monoxide, carbon dioxide, soot, unburned hydrocarbons. We call those particulate matter, PM 2.5, PM10, ultrafine. We got oxides of nitrogen, or NOx, and sulfur oxides, often sulfur dioxide, but also other sources too. A lot of the sulfur comes from electric utilities. Mostly coal is the really big one for sulfur dioxide. And then NOx comes from combustion of fossil fuels, especially from driving vehicles. In the presence of sunlight, you might also have some secondary pollutants that form primary pollutants with some reaction. So nitrous oxides can interact with oxygen to create nitrogen dioxide. And so that creates the little haze you see over cities. And then that could react with sunlight to release a single free oxygen, and that O1 might join with O2 to create tropospheric ozone. And ozone down here is not a good thing, but a great example of a secondary pollutant, because you have to have that interaction between free oxygen and then O2 as well. So we see the nitrogen dioxide right here, and the energy from the sun splits one of those oxygen molecules off, and that oxygen joins with an O2 to create O3, tropospheric ozone. Bad. It's bad because it creates smog, but also tropospheric ozone has like health effects too. Ozone can actually like harm and destroy DNA. Here's a great example of some damaged plant cells, which were ravaged by tropospheric ozone. Can also give you respiratory effects or irritate your eyes. Can cause like fabrics to damage. Smog is a complex mixture of primary and secondary pollutants, but tropospheric ozone is a really big one, which is why you see such a change in smog as more people start to drive their cars. Some more examples of health effects, and then another diagram showing all the different chemicals involved here. The frequency and severity depends on topography, the shape of the landscape, the climate, the amount of people living there, and how much fossil fuels they're burning. Of course, if you burn more, it's going to be dirtier. If you burn less, it's going to be less dirty. So a few examples. I mean, we have thermal inversions. So in normal conditions, the cooler air will sit on top, and warmer air is closer to the surface. Just sort of a relation factor of how temperature works. Temperature is just how often molecules bump into each other. Down here, the molecules are closer, so they bump into each other more. And as you go up, the molecules are further away, so they bump into each other less. In an inversion, you get that warm air trapped in between colder air. So the pollution can't actually rise. It gets stuck. And then like if you climb a mountain, sometimes you actually can just see like a cap of pollution above a city. It's pretty astounding. Deforestation and burning may also contribute to smog, as we saw in New Delhi, India, as the burning of crops to clear land created huge spikes in air pollution. And there's economic losses from urban air pollution, which sometimes convince more people more than health or environmental losses. But you know, when people can't go to work, they're going to have economic effects. If people are sick, you have to deal with all of that, like Um, so some figure three activity for you. We could alter the human activity by consuming less fuels, ride your bike or use some shared transit. We could regulate and reduce the pollution um, by government regulation and taxing. We have carbon pricing in this case. Or you might have, like the Environmental Protection Agency or the Clean Air Act, which has regulations about the types of pollutants that can be created. Catalytic converters are on just about every car these days. Definitely in the U.S. I'm not sure what the standards are like in other countries, but they especially deal with nitrogen oxides to reduce that tropospheric ozone and really help diminish the photochemical smog. And then we have some examples of, let's see, this would be regulation. Aha, great. Okay, so grams of carbon dioxide produced per megajoule of energy. So a lot of times, there's this idea that we could use some biofuels, but a lot of biofuels actually still produce a lot of carbon dioxide in their production. It's really kind of a funny issue, right? But like you grow corn to make corn ethanol, but then you're driving a tractor which is burning fossil fuels as you make this corn ethanol. One of the biggest ways that we would think about trying to clean up and restore the environment might be to try to sequester carbon dioxide, take it out of the atmosphere and put it down into the ground or into other places where it's not going to affect the climate. Or we have examples of technology that actually removes pollution directly from the atmosphere. So you should be able to evaluate different pollution management strategies at those three different levels from figure three. And then international mindedness, again, like you can imagine, you have this situation in India with New Delhi. I mean, that pollution blows across the border of India too, into other places. Shout out to Brad Kramer for his excellent slideshow.